So CRISPR. So like for someone who maybe never heard of it or just maybe barely heard it, like what is it?
So I know it sounds like the like the little section in your fridge where you put the the lettuce, the CRISPR section, but
Or like a cereal.
Yeah, or there you go, or Krispy Kreme or something. But yeah, it's actually, so the word CRISPR is an acronym, and it's a little complicated to unpack, but basically what it stands for is clustered regularly, I hate that word, clustered regularly interspaced short palindromic repeats.
Okay.
And so that doesn't mean anything to hardly anybody in the world. But what those things are what it's referring to, the acronym, are actually just short sequences of DNA that actually exist in bacteria. We can get to why that is in a minute, but it's essentially a system that bacteria have. It's like an immune system that bacteria have to defend themselves against infections, and bacteria get infected by viruses.
Right.
So I can talk about this a little bit. My background is as a microbiologist. I have a Ph.D. in microbiology. Yeah, go ahead.
Yeah. So like you have a PhD in microbiology.
Yep. And
is this all this CRISPR stuff, gene editing? That's not microbiology, is it?
No. So essentially, where I was getting to is that this CRISPR system, if you will, this immune system that bacteria have, was first discovered by microbiologists in bacteria. Right. And so where the the truly innovative, inspirational idea that's happened is to actually utilize this system that bacteria have as a way to do gene editing in other types of cells, specifically human cells or mammalian cells. But really, you can use the technology in any kind of cell, we found out. And that's because all living things have DNA, right? So, and it turns out that these, these nucleases, if you will, so they're enzymes that can cut DNA, even though they come from bacteria, can actually work in any cellular environment.
So is CRISPR like discovered and then is found ways to be like used, or is CRISPR something that was like invented by humans, or it was discovered in the cells that you were talking about?
Yeah, it's a little bit of both, right? Because I'm not sure if your listeners will know this, but recently a Nobel Prize was awarded for the discovery of the CRISPR technology, and that was given to Jennifer Doudna, who is a microbiologist and a biochemist at UC Berkeley, and also Emmanuel Charpentier, who is a researcher over in Europe. And they co-discovered that you could utilize this system, if you will, in a different outside of where it was discovered in bacteria. So yeah, it was discovered originally. These repeats of DNA, what they are, if you think about it, it's a form of memory. And so in our own immune systems, every time you have an infection, you will develop immune memory against that virus or bacteria that infected you. So in the future, you can fight it off really quickly. So this is actually how our vaccines work, right? Like the COVID vaccine.
It's relevant now with that going on.
It's relevant, yeah. So COVID vaccine, most of them, like, we're probably getting here in the US, the Pfizer, Moderna, they're giving us a piece of RNA that our bodies will turn into a piece of DNA naturally, because that's what cells do. And let me back up. Sorry. You're getting a piece of RNA. Misspoke there. You're getting a piece of RNA in this vaccine. Your body turns it into a protein, which is what cells do. And your body recognizes that as a foreign protein, makes antibodies, and now you're protected against a future infection with coronavirus.
That's so cool.
And so with CRISPR, essentially what the bacteria are doing is when they get infected by viruses, they're saving little pieces of virus DNA in this kind of storage area in their own DNA genome. And what they do is they use that as a way, when they get a future infection with a virus, they can destroy the virus. They can cut the virus's DNA to pieces, which will protect them from infection.
Yeah, it's like an intelligent army, like learning what their enemies are going to attack them with, learning what they would get attacked with, and then like in the future when it comes, they already know how to like combat it.
Exactly. So they can, they already have their armor ready to go. So it's kind of like I think what was really innovative and groundbreaking. So these discoveries were made by several groups, but really the person who gets the most credit is a scientist who lives in Alicante, Spain, which is a fantastic place to go for vacation, if you ever want to. But his name is Francisco Mojica, and he discovered these elements in bacteria in the 1980s. Once we started to sequence a lot of bacterial genomes, because sequencing technology was starting to really come up then. And for a long time, I think people didn't really understand what they were. And through a series of scientific research and rigor, it was discovered that they're a type of immune system. And because they're storing a memory of these viruses that infect only bacteria. And so, really kind of the aha moment became, the way that these nucleases work, that they identify and destroy the virus DNA, is that they actually use a piece of their own RNA. They call it a guide RNA. And that directs the CRISPR machinery, which is just a protein and nuclease, to a specific location where the virus DNA is hiding. So virus DNA integrates into genomes and hides there. That guide RNA will take that protein to that specific address, right? If you think about it, it's kind of like a piece of software, right? The guide RNA is like a piece of software that's telling this hardware, which is a protein, where to go, a specific address in a genome, and to make a cut and to help it remove that piece of virus DNA. So the idea aha moment, which was first documented by Jennifer Doudna, Manu Charpentier, the Nobel Prize winners, and some others like Feng Zheng, it was really just to say, hey, this approach, we could actually co-opt this and use it in a different type of cell, another cell, just to show that you could target a specific piece of DNA if you just give it the right program, if you give it the right piece of guide RNA to take it to that location.
That's so powerful. And
it's really powerful, yeah.
It's incredible.